Okay, so now let us consider a scenario where you have two consumers, two goods. Okay, again, we'll be just right now talking about Pareto efficiency. Okay, later on I'll be talking about competitive equilibrium. Okay, so so now we have two consumers. Okay, is that fine? Okay, so let's name those two goods X and Y. Let's say these two consumers are 1 and 2. Okay, so again, I'm going to first describe the environment. Okay, so we have two consumers, two goods. Okay, it's a pure exchange economy. Each individual has some endowment of X and Y. Okay, so let's say this is omega 1 X, omega 1 Y. Okay, so this is the endowment of individual 1. And then you have omega 2 X, omega 2 Y. Okay, this is the endowment of individual 2. Okay, and let's say we have utility function which represents the preference of consumer 1, and it's given by U1 x1 y1, well, also x2 y2, because we are considering scenarios where there is externality. Okay, so u2 is a function of x1 y1 x2 y2. Okay, is that clear? So this is the scenario that we have here. Have you all understood this? Any questions about the setup of the model? Okay, so once we have this, again, we can talk about, how to represent the set of all feasible allocations, and then how to figure out Pareto efficient allocations. Okay, now, even though, you can see that there are 4 variables here, you might say that, it might be difficult to work with, but it's not. We can always convert this into, using the feasibility constraint, we can convert them into adjusted utility functions, and you can convert them into 2 variable functions. Because when we are talking about Pareto efficiency, I repeat, when we are talking about Pareto efficiency, we are comparing one feasible allocation with the other. So feasibility constraint is already in there. Okay, so what we can do is we can just apply the feasibility constraint. Okay, and just rewrite this in the usual manner, which is utility as a function of just x1 y1. Is that clear? Okay, great. Okay, so now let's do some problem. So let us say omega 1 x omega 1 y is 2 0. Okay, and omega 2x omega 2y is 0 2. Okay, so do you want some utility function of your choice, or do you want me to give you some utility functions? Okay, max. Okay, you want negative externality. Okay, okay, fine. Okay, so what we can do is, let's take maybe one negative externality. Okay, and the other is, let's say, some max. Okay, so is that okay? Okay, so we can have maybe something like this: x1 plus y1. So how do you write, something where you are having negative externality? Okay, so you can maybe just add a minus sign. Let's say if you are negatively affected by other players' consumption of x, then you can just put minus x2. Okay, I'm just giving you an example. I mean, there could be other ways. You can have minus square root of x2 or something like that. You can also have minus x2 squared, or you can have minus x2 by 3. So all these are, different ways in which, you can represent a negative externality to player 1. Okay, so let's consider the simple setup where we have x1 plus y1 minus x2. Okay, and do you also want negative externality for y, or just this for y2? Okay, so yeah, so basically, if it is for y as well, you can just add another term minus y2. Okay, uh, so this is one specific situation. Obviously there are other ways in which you can have a negative externality from both x and y. Okay, but let's just consider this one. Okay, this is, let's say, is the utility function of consumer 1. And what about the utility function of consumer 2? So you said max, right? Okay, so do you want max? Okay, let's do this. Max of x1, y1, x2, y2. Is that okay? Okay, so now again, what you can do is it's just straightforward. You can just first convert them into adjusted utility function, because feasibility is something which is implicit in this particular problem. Okay, so when we are asking this question that whether a particular allocation is Pareto efficient or not, we are asking whether there exists a feasible allocation that can improve the satisfaction level of one without reducing the satisfaction level of the other. Okay, so what you can do is you can use this feasibility, okay, to just write the utility function in this way, and then you can figure out the set of all Pareto efficient allocations. Okay, so u1 is equal to, so you can just replace x2 by 2 minus x1. Okay, and then you can replace y2 by 2 minus y1, right? And then what you're going to get is 2x1 plus 2y1, okay, minus 4. Okay, please note that this particular utility function, okay, this is the adjustment which only works with these endowments. Okay, and it's, if you want to change the endowment, the adjusted utility function will be different. Okay, so similarly you can just write utility function of individual 2. You can replace this by 2 minus x2, okay, this by 2 minus y2, okay, and then this is going to stay as it is, x2 y2. Okay, now what we can do is we can plot some indifference curves in the Edgeworth box, and then figure out Pareto efficient allocations in the usual way. So it's just straightforward. Okay, so I'm going to draw a box. This is origin of 1, this is origin of 2. Okay, so individual ones references are very easy. The indifference curves will be straight line with the absolute value of slope equal to 1. Okay, so you can just easily draw them, right? I mean, let's just take red color for the first individual's indifference curve. So they'll be like this, right? Okay, and this is the direction in which the utility is increasing, right? Now let's think about the second individual. Okay, now can you tell me what is the maximum utility that an individual 2 can get in this entire box? Exactly, the maximum satisfaction is 2. Now why is it 2? Because you can easily see that the highest amount of x available in this economy is 2, and highest amount of y available in this economy is 2. So if you can either look at this or you can look at this, none of them can be more than 2, right? I mean, that's not possible. X1 cannot be more than 2, y1 cannot be more than 2, x2 cannot be more than 2, y2 cannot be more than 2. So definitely it's bounded above by 2, the satisfaction level, right? Okay, so the maximum possible utility is 2. Okay, so what all points gives this particular individual maximum utility? So basically I'm asking you the indifference curve for 2 level of satisfaction. X1 is 0 or y1 is 0, that's right. But so x1 is 0 means this, right? Y1 is 0 means this. So only these points. Yeah, you are right that these points are on the indifference curve, that's right. So are there other points that are on the indifference curve? Well, when x1 is 0, definitely x2 is 2, so the utility will be 2. When y1 is 0, y2 will be 2, so therefore utility will be 2. When x2 is 0, x1 will be 2, so the utility is 2. When y2 is 0, x1 is 2, so the utility is 2. So basically it gives you all 4 boundaries of the box. This is where x1 is, this is where x1 is 0, this is where y1 is 0, this is where this is where y2 is 0 and this is where x2 is 0. Okay, so all these points on the box, on the boundary of the Edgeworth box, are Pareto efficient, right? So basically you have an indifference curve which looks like a square. Okay, now can you tell me inside the box what is the worst point for this particular person? Very good. It is the center, 1, 1. Okay. The reason is because, so if this is less than 1, then that makes this more than 1 because this is 2 minus x1, right? So whenever any of them is less than 1, there will be a corresponding quantity which will be more than 1. So the utility will be actually bounded below by 1. And the only way you can achieve 1 is, if all of these are 1, right? Okay, so this is, you can say, another indifference point or indifference, whatever curve you want to call it. I mean, it doesn't look like a curve, but it's just indifference, okay, point. Is that fine? Okay, now let us draw one more indifference curve so that we get an idea about, how the preference looks. Okay, so you can just pick any utility level between, let's say, 1 and 2, because 2 is the maximum possibility, 1 is the minimum possibility. So if you want to draw some indifference curve, you have to pick a utility level between 1 and 2. You can pick, let's say, 1.5, for example. So can you tell me what will happen, if you want to draw an indifference curve for 1.5 level of satisfaction? How's that going to look? Okay, I've just drawn a diagonal. Okay, that's it. Okay, so do you agree? Yeah, so it will be a square. That's right. Okay, so you guessed it right. Okay, it will be a square. But let's first see what will be the location of this square. Okay, so I mean, I can draw a square like this, I can draw a square like this, or I can draw a square right here. Which one? Okay, so what we can do is, we want the satisfaction level to equal 1.5. So u2 to be 1.5, right? Okay, so if u2 is 1.5, do you agree that one of them must be 1.5? So either x1 is 1.5 or y1 is 1.5 or x2 is 1.5 or y2 is 1.5. Do you agree? One of them, like at least one of them must be 1.5. Do you agree? Yes. So what we can do is, we can draw a superset, okay, of the indifference curve first, and then we can just eliminate whatever uh, whatever region is not going to satisfy this property that the max is 1.5. Okay, so first let me draw x1 equal to 1.5. So can you tell me what is the location of x1 equal to 1.5? Where is this line x1 equal to 1.5? Remember that this is 2, this point is 1. Okay, so this is 2. Okay, so where is x1 equal to 1.5? Where should I draw x1 equal to 1.5? This is 1.5, right? X1 equal to 1.5 will be a vertical line, right? Okay, like this. Okay, it will be a vertical line like this. Do you agree? Okay, so this is 1.5. Okay, now other possibility is that y1 is 1.5, so we can also draw y1 equal to 1.5, right? So how do you draw y1 equal to 1.5? So what we can do is we can use the fact that these are 45-degree lines, this is a square, okay, and then it's just very, very simple, because if this is 45-degree line, okay, and this is a square, then this length is 0.5. So if you want to plot y1 equal to 1.5, then you can just look at maybe this thing. Okay, so what is this intersection? Okay, what is this point? Okay, so basically you will get something like this. Okay, and you can easily show by geometry that this length will be exactly 1.5. Is that fine? Okay, and similarly, this length will be, this is basically a y2 equal to 1.5, and this is equal, and this is basically x2 equal to 1.5. Is that fine? Okay, and now because we want the max to be 1.5, okay, we don't want any of the other quantities to be greater than 1.5, right? I mean, if the max of this is 1.5, then let's say if x1 is 1.5, we don't want y1 or y2 to be greater than 1.5. So we want to remove all the regions where either x1 is greater than 1.5 or y1 is greater than 1.5 or x2 is greater than 1.5 or y2 is greater than 1.5. Okay, so notice that x1 is 1.5 here. In this region, x1 is greater than 1.5. So what that means is, this portion, okay, is not part of the indifference curve. Okay, similarly, this portion is not part of the indifference curve because x1 is greater than 1.5 at these points. Okay, similarly, at these points, you can see that y2 is greater than 1.5. So I'm going to remove this. Okay, and here x2 is greater than 1.5, so I'm going to remove this. Okay, and here y1 is greater than 1.5, so I'm going to remove this. Okay, and now you can see that along this square, okay, which is like this. Okay, along this square, okay, you can see that if you pick any point like this, then at this point you can see that x2 is 1.5. Okay, and both y1 and y2 are less than 1.5. Okay, and of course x1 is also less than 1.5, so the max is 1.5, and this is something which is true about all these points. Is that clear? Okay, very good. Okay, so now once you have plotted this indifference curve, and this is the indifference curve, and this is also 1 point indifference curve, so now you can figure out which way the direction is, the direction of preference is. So you can see that as you move outwards, okay, towards the boundary, this consumer gets better off. Okay, this consumer number 2, okay, gets better off. So this is the direction of preference. Is that clear? Now we just need to figure out set of all Pareto efficient allocations. Okay, so what do you think? What will be Pareto efficient? Now that you know the indifference map, you know the direction of preference, what do you think is Pareto efficient in this case? Origin of 2? Okay, origin of 2 is Pareto efficient, that's right. Are there other Pareto efficient allocations? This one. Okay, let's just quickly check. Okay, let's check. So if you move from this point to this point, what happens? You can make both of them better off, right? Okay, so in fact all the allocations except this one, okay, are not efficient. Okay, because no matter what point you pick in this box, if you pick this point, you can see that the the IC through this point of uh, individual 1 will look like this. Okay, and of individual 2, it's going to look like this. So I see through this point, okay, will look like this. Okay, so basically you can, if you are here and you move here, okay, then individual individual 2 will be on a higher IC because that's the highest box where he gets the highest satisfaction level, and individual 1 will also be on a higher IC because he'll be on a higher satisfaction level if you move in this direction. Okay, so basically all the allocations inside the box in are are Pareto dominated by this particular allocation, and therefore every allocation inside the box is uh, uh, is is not efficient except this one. Okay, only one allocation is Pareto efficient in this case, which is individual 1 consumes 2, individual 2 consumes 0, 0. Okay. Okay, now this particular problem can also be done, straight away if you really think about it. This individual wants to consume more of both x and y, right? I mean, if you just look at his adjusted utility function, uh, his preference is increasing in both x and y. Okay, and this guy, if you really look at individual 2, his preferences are such that he likes extremes, in the sense that if any of them is 2, he'll be happy. Okay, if any of them is 2, he'll be happy, right? So what that means is, if you just give all the endowment to individual one, he's kind of fine with it, because he's again in the extreme, in the sense that these are 2, right? I mean, sorry, these two values are 2. Yes or no? If these 2 are 2, so this is the best that can happen to individual 2. So 2 not only maximizes individual 1's utility, but it also maximizes individual 2's utility. Okay, so if you really think about it, this is the allocation which will be Pareto efficient, right? I mean, this is the allocation that maximizes the utility of both the individuals subject to the feasibility constraint. So if it maximizes the utility of both the individuals subject to the feasibility constraint, then obviously, and it is a unique maximum for both. Okay, so then obviously, there is no other allocation which is going to be Pareto efficient, because this allocation is going to be Pareto superior to every other allocation. Is that clear to everyone? Okay, so that's just one way in which you could have done this without plotting this graph.